learners, welcome to Education Online program. In our previous lesson, we looked at the differences between the three forms of heat transfer, and we also looked at the factors affecting the heat transfer. With the factors, we looked at the temperature as one factor that affects heat transfer. We looked at the specific heat capacity. We talked of the mass of the object or the substance. So those are some of the factors that affected the heat transfer. Then when we came to the differences between the three forms of heat transfer, the convection, radiation, and the conduction, we say that conduction is usually witnessed in solid objects. So for it deals with the electron particles in the solids. With convection, we looked at the molecules of liquids and gases, which is just the same with other radiations, which we talked about the electromagnetic waves. So these electromagnetic waves, we say they also move with the speed of light. So today we are going to look at the applications of these forms of heat transfer. Applications. Heat transfer. To make it more simplified, we shall look at them according to the forms of the heat transfer. So we are going to start with the convection. So we shall have the convection in gases. So we shall first look at all the applications under the convection. Let's have our convection. Since we say that it deals with the molecules. So what other applications can we have? The uses of this convection. We see that we can apply the theory of convection form of heat transfer in land and sea breeze. So that will be our first application there. We'll have land and sea breeze. So what is this land and sea breeze? When someone is talking about that, what are they talking about? What do they mean? So with land and sea breeze, we are meaning this wind, any wind that is blowing from a large water body towards, or it blows onto the land. So if that wind is blowing, that exchange of wind from land to the sea or from sea to land is what we refer to as the breeze. So we shall start with the land breeze. But then before we go to the land breeze, what causes this exchange of air between the land and the sea? So we see that comes about because of the difference in the air pressure. The air on top of the land has got different pressure from the air that is on the surface of the sea. So what causes also that difference in the air pressure? So you find out that this difference is being caused because of the difference also in the specific heat capacity. Land has got different specific heat capacity from the sea, because the sea is comprised of what? the sea has water. So you see that the two do not have the same specific heat capacity. And because of that, they cause the air pressure on them to differ from each. So we're going to look at the land breeze. So our first is land. So we shall start with the land breeze. How does this land breeze occur? So you see that to find the effect of any breeze, you will need the land. And then you need the what? The water body. So at this case, we are going to take the land and we shall take the sea. Let's have a simple diagram of the land and the sea. So we shall have our land is higher than the sea. They are not at the same level. Land and any water body are not always on the same level, meaning that one should be higher than the other and then the other one is lower. So we shall have here, we assume this is our land that is on top there. So if we have the land, we shall need the sea. Where is the sea? Does it go above or it is below? Our sea will be below here. Let us have this. Let's have a proper diagram. We shall have this one there. We shall get this. Here. We are trying to have our land and then the sea. So the raised part here is our land. So we can have it there as land. So the water body is always below the land. So we shall have it here. So this is now our water body. So how does the wind blow from the sea to the land? We call the wind that is blowing as the air currency. So how will the movement of this currency be like? So we shall have it here. We assume this is where the circulation is happening. And then here. Let's have something like that. This one is just to show us the movement of the air currency from the land and the sea. So you'll see that at what time does this land breeze occur? Land breeze always occur during the night hours. So you find out that at night air is cooler, but on which side? If you see the sea and the land, which surface actually cools fast? At night. So you see that land cools faster than the sea. Why does it cool faster than the sea? Because it is a very good, or it is a better emitter. Emitter of what? It's a better emitter of heat. So that means that if it can emit heat faster, the air there will be cool, because as it is emitting the heat, it is emitting the energy, it is transferring the heat from one point to another. So it will be moving this way. This one has warm air, it goes up, and then this one down like this is how the circulation will be like. So here is our air currency. So you find out that at night the land here will cool faster than the sea, because it emits all its energy. So if it is cool, the air here on the land is cool, meaning that the air surrounding the water body is actually warm. It is warmer than the one on the land. So what happens is that this one will be reduced. It will gain kinetic energy which is greater than that. So you see that when kinetic energy of a substance increases, what happens? The molecules in that substance tends to move faster. So if it is moving faster, this air will escape to the space. So the sea will release the air currency to move upwards. So if it is moving upwards, what happens? Up there, remember, the air is also cool. So it is moving from the more dense to the less dense area. So you see that the air that reaches here will cool. So when it is up here, it cools, it goes to the land. So since this air here is it's cooler, and then this one has escaped to the surface, that means the currency from the surface of the from the land will come and occupy the space that this currency that was at first here left. So it will come and occupy this space. So that's why you see that at night this land becomes more cooler than the sea. So that is the land breeze. With the land breeze, the cooler breeze comes actually from the land. This time round from the land to the sea. So what happens when it is now the sea breeze? We have it as the sea breeze. With the sea breeze, how will the circulation look like? So you see that if you have your land, so this is our land here. We create some space for the water body, since it's supposed to be below, as we said previously. So this is still our water body. We can say it is the sea, and then this one is the land. We still have the currency also circulating on top of the land and the sea. So if we have it here, so that is we are taking this one to be our air currency. So this is how the movement of this air from the sea to the land, or from the land to the sea, will be looking like. So if we say that a land breeze normally occurs, if you say it occurs at night, what of the sea breeze? The sea breeze occurs during the day. So it occurs during day. During the day, when you have when you go next to any water body, any river, try to step on the sand around and then the water. What happens? You see that the sand is a bit warmer than the water. So why is that? So you see that when it comes to the to day hours, what happens is that during day the sun rays come. When they come, they fall on the water body, and at the same time on the land. So, but because the land is a good absorber of heat than the water, and then it has a lower specific heat capacity than the water, you find out that this land is going to warm faster. So if the land warms, that means that the air around the land is actually warm. What of the sea? Because it heats up slower than the land, the air around the surface of the water body or the sea is going to be cooler than the air around the land. So if it is cooler like that, what happens? So you see that the air around this will escape, will go upwards, because their kinetic energy will be increased. The kinetic energy is increased due to the fact that there is increase in the temperature. Because if there is increase in the temperature, that means that it's going to be hot. And when something is hot, it expands. So you find out that the molecules around here will have more space, and they will move faster, randomly and faster than the molecules that are in cooler area. So this one here, the currency on top of the land will tend to move upwards. So if it is moving upwards, our currency will take the arrow up. So if it moves that, what happens? It does not just remain in the space. Remember, there is currency also on the surface of the water body. So what happens to this currency that is on the surface of the water body? This currency, they are going to move. They will move and then replace the currency that was at first on the land surface, because these ones have now escaped to the space. So you see that this one, the currency from the sea, will now come and occupy this space. So when it comes and occupies, that's when you find that it is now tries to cool the land. So this is why it is called the sea breeze, because the breeze, the cool air, comes from the sea at this point and then onto the land, which is a different case with this. With the land breeze, the currency, the cooler air comes from the land, and then it is replacing the warmer air that was being transferred from the surface of the sea. So that is one of the applications of convection in gases. So let's look at another application, which is known as we shall have it as the ventilation. We have it as, this is number 2. Shall have it as ventilation. Okay, this one we can take an example of our buildings. How is your house constructed? You see that during construction of a house, assume this is our house, this is the roof. If we have the roof, what else? We have the walls. Do we only have the walls on the house? No, we also have the doors. So what else do we have still in the house? We have the windows. So this is our window, and this is the door. Yes. For the door, we know that when you're building a house, you can build a house and you need a door. Why? Because you always think that the door is just for entering inside and coming outside. Why did we put the window? Is the window for you to enter also inside the house and come out? If not only the window, when it is a concrete building, you see that there are some things, if Even though we have our door, there are some holes that are created right up here. Why do we put so many of these openings on the house? This is because of this heat transfer. So you find out that in the house, when you enter, let's take an example of Juba here. It is very hot. When you enter inside, what happens? You find the air inside there very, very hot. That's why we have the windows and we have the ventilators. Why? This is because when the air inside there is now hot, when the air is heated during the day like this, we shall need to replace the air, because as the air inside is hot and the space inside is actually warm, what happens is that there will be increase in the kinetic energy of the molecules of the gases inside the house. So when it is increased like that, there will be in random motion. Now if you want to cool your house, what will you do? You see that you'll open the windows and the doors. Why do we open the windows and the doors? This is to help a cooler air to enter the house, because when you find that they want the warm air inside, if it is in a very high motion, it is going to move out. So when it is moving out, that means that this other cool air will enter inside and replace the hot air. That is the reason why we have the ventilators. This is to help us take it more cooler air when it is very hot. Even the doors and the windows help for that reason. The window is not there for you to jump inside and come out, but it helps to regulate, to circulate cooler air as the warmer air comes out of the house. So we also have so many applications of this. We can even talk about the chimneys in the kitchens and the factories. We have the ventilation pipes in the VIP toilets. Those are all applications of convection, form of heat transfer in gases. What of the radiation? We also have the applications of radiation as a form of heat transfer in gases. Let's look at the radiation. How do we apply the effect of heat transfer in the heat of with this form here, radiation? You'll see that with radiation, mostly the applications are on the black and the dull surfaces. It can be dull or it can be bright. So the surface of any object determines the application, the use or the effect of this radiation. Let's take a look at the teapots as one of our applications. We can talk of the teapots or the kettles. Why is it that the teapots are actually polished silver? They are shiny. Why? They are shiny like that because we want them to have we want them not to emit out the heat. We want them to store the heat, because if you boil tea in the teapot, you will want this tea to remain hot. If you want it to remain hot, that's why we are saying that the surface is polished white. So if it is hot, that means that the emission rate of heat is going to be low. So we also have the solar panels. We apply this on the solar panels. You find that solar panels are polished what? Solar panels are actually dark. Why are they dark? They are black. They are polished black because that black there is a very good absorber of heat, because we want the radiations from the sun to come, and then the solar panel is going to absorb it, take it in. So that's why you find out that this one is polished white, black, to absorb the heat from the sun. So it has got also very many other applications where we talk about the car radiators. The car radiators are painted what? They are black also, to easily emit heat. So if you're talking about the applications of heat transfer, you find out that there are really so many applications. Some of them we also, it applies to us, the human beings, but in most cases we do not take note of that. Like the choices of clothes we make, you find out that most of the times during cold weather, how do people dress? When it is cold, you find out someone just prefers wearing a wool, something very hot, which is more like black. So because this black here is doesn't emit heat that easily, it keeps the heat inside your body to warm you up. What of during hot days? You find out that dressing in let me say bright clothes is much better, because it emits the heat. So when it emits the heat, that means that it is a poor absorber of heat. The bright surface does not bring the heat, absorb it to yourself. So you see that during day, when it is hot and you put on black, you're going to feel the effect of heat more, because there is a transfer, the radiation transfer of heat from one place to another happens. There the sun is going to radiate the heat, and then the body will absorb if you're in black. But then when you're in colored, other colored clothes apart from black, you maybe white, you see that when the radiations from the sun comes and falls on you, the cloth is going to emit that heat instead of absorbing it onto your body. So these are some of the applications. We shall still look at more applications, like the thermal flask. We still have, those are some other applications of the heat transfer, and we shall see that in our next lesson. So with this, we come to the end of our lesson. We shall meet again.